On July 14th, 2015, at 11 hours and 49 minutes, Coordinated Universal Time, a spacecraft the size of a grand piano, traveling at 49,000 kilometers per hour, skimmed 12,500 kilometers above the surface of Pluto. The spacecraft was too busy taking measurements to send back any data during the flyby itself. 14 hours later, the first high-resolution images reached Earth after traveling across 7 billion kilometers of space. And there, in the first clear photograph of a world that human eyes had never actually seen before, was a heart. A vast, bright heart-shaped region of nitrogen ice more than 1,000 kilometers across, sitting in the western hemisphere of Pluto, gleaming against the darker surrounding terrain. Scientists in the Mission Control Room at the Johns Hopkins University Applied Physics Laboratory in Maryland went quiet when they saw it. Some of them cried. It was not what anyone had expected. This distant, cold, dark world at the edge of the solar system had a heart, and it was enormous. Tonight, we go to that heart. We go to Pluto, to its great moon Charon, and to the extraordinary spacecraft that crossed the solar system to reach them. Everything I am going to tell you is true. Every measurement, every discovery, every extraordinary detail of this world and this mission. By the time we are finished, you will understand Pluto not as the point of light it was for 85 years, not as the demoted former planet it became in 2006, but as the complex, surprising, geologically alive world it actually is. A world with mountains made of water ice as tall as the Rockies. A world where glaciers of nitrogen flow across plains of frozen gas. A world that, despite being 4.5 billion kilometers from the sun, has a thin, layered atmosphere and haze that reaches hundreds of kilometers into the sky. Before we begin, take a slow breath in, let your lungs fill all the way, hold it for a moment, and breathe out slowly, feeling your whole body settle and release. Let your eyes stay gently closed. Let the sounds of your environment fade into a soft background. You are safe and warm, and we are going on a journey to the very edge of the known solar system. Let us begin with the story of how Pluto was found. Because Pluto's discovery is one of the most human stories in the history of astronomy. In the late 19th century, astronomers had used the observed perturbations in the orbits of Uranus and Neptune to predict the existence of undiscovered planets. The same mathematical technique that had led to the discovery of Neptune in 1846 from the observed wobbles in Uranus's orbit was applied again. A wealthy American businessman and amateur astronomer named Percival Lowell became convinced that there was a ninth planet, which he called Planet X, perturbing the orbit of Neptune. He devoted the last years of his life and a significant portion of his fortune to searching for it, building an observatory in Flagstaff, Arizona that would bear his name. He searched for years without success. He died in 1916 without finding Planet X. The search continued after Lowell's death. The Lowell Observatory hired a young Kansas farm boy named Clyde Tombaugh to take on the task. Tombaugh had no formal astronomical training, but he had built his own telescopes and demonstrated such careful observational skill in his correspondence with the observatory that they hired him. His task was to photograph the sky systematically and examine the photographs for a moving object that would stand out against the fixed background stars. The technique Tombaugh used was painstaking beyond imagining. He would photograph the same region of sky twice, several days apart. Then he would place the two photographs in a device called a blink comparator that rapidly alternated between showing one image and then the other. Any object that had moved between the two photographs would appear to jump back and forth when the images were alternated. A planet would move, a star would not. Tombaugh would scan systematically across each pair of photographs, examining every point of light, looking for anything that jumped. He did this for nearly a year, examining millions of star images. On February 18, 1930, while examining plates taken on January 23 and 29, he noticed an object moving against the background. He checked it against a third plate taken on January 21 to confirm the motion. The object was real. It was moving. It was a new world. Tombaugh walked to his supervisor's office and announced, quietly and characteristically without drama, that he had found Planet X. The announcement was made to the world on March 13, 1930, the 149th anniversary of the discovery of Uranus and the 75th anniversary of Percival Lowell's birth. The name Pluto was proposed by an 11-year-old English schoolgirl named Venetia Burney, who thought the name of the Roman god of the underworld was appropriate for such a cold, dark, distant world. The name also pleased the Lowell Observatory because its first two letters, P and L, were the initials of Percival Lowell. Pluto was accepted as the name. Clyde Tombaugh spent the rest of his life closely associated with the planet he had discovered, and his ashes were placed aboard the New Horizons spacecraft that would eventually reach it. When New Horizons flew past Pluto, it carried the ashes of the man who found it. For the first several decades after its discovery, Pluto's nature was largely unknown. Its size was difficult to determine from Earth because it appeared only as a tiny point of light, even in the largest telescopes. Early estimates of its size were wildly overestimated. Some astronomers initially thought it might be larger than Earth. By the 1970s, improved measurements had reduced the estimates considerably, but Pluto remained frustratingly enigmatic. The discovery of Pluto's largest moon in 1978 transformed our understanding. On June 22, 1978, an astronomer at the United States Naval Observatory named James Christie was examining photographs of Pluto and noticed something strange. Pluto appeared elongated in one direction on some photographs, as if it had a bump attached to it. He realized this was not a photographic artifact, but a real object, a moon orbiting so close to Pluto that it was nearly unresolvable from the planet itself in images of that era. The moon was named Charon, after the ferryman who carries souls across the river Styx in Greek mythology to the realm of Pluto. The name also pleased Christie personally because his wife's name was Charlene, and he called her Char. The discovery of Charon allowed scientists to measure Pluto's mass with precision for the first time, because the orbital period and separation of a moon determines the mass of the body it orbits. Pluto turned out to be much smaller than previously suspected, its mass only about 0.2% of Earth's mass. It was clear that Pluto was not Planet X in the sense Lowell had imagined. It was too small to have produced the perturbations in Neptune's orbit that had motivated the search. As it turned out, The perturbations that motivated the search were largely illusory, artifacts of imprecise measurements. Pluto was found by a combination of persistence, technique, and luck, searching in the right place of the sky for the wrong reasons. Let your breathing continue to slow. The story of Pluto is just beginning, and it is extraordinary. Pluto orbits the Sun at an average distance of about 39.5 times the Earth-Sun distance, but its orbit is highly elliptical, more so than any planet's orbit, ranging from about 29.7 to 49, 3 times the Earth-Sun distance over the course of one Pluto year. A Pluto year, the time it takes to orbit the Sun once, is 248 Earth years. A Pluto day, the time it takes to rotate once on its axis, is about 6.4 Earth days. Pluto's axial tilt is about 122 degrees, which means it rotates essentially on its side relative to its orbital plane, similar to Uranus. This extreme tilt produces extreme seasons over the course of Pluto's very long year. At its closest approach to the Sun, Pluto is actually inside the orbit of Neptune. For 20 years of every Pluto year, roughly every 248 years, Neptune is actually farther from the Sun than Pluto is. This was the case between 1979 and 1999, meaning that for 2 decades of living memory, Neptune was technically the most distant planet, and Pluto was the 8th. Pluto and Neptune never collide or closely approach each other because their orbits are in a 2 to 3 resonance, meaning Pluto completes exactly 2 orbits for every 3 of Neptune's. This resonance keeps them safely separate. Pluto is now known to be a member of a vast population of icy bodies that orbit the Sun beyond Neptune, called the Kuiper Belt. The Kuiper Belt is named after the Dutch-American astronomer Gerard Kuiper, who hypothesized its existence in 1951, though earlier astronomers had also proposed the existence of trans-Neptunian objects. The Kuiper Belt extends from about 30 to 50 times the Earth-Sun distance and contains hundreds of thousands of icy bodies larger than 100 kilometers across, along with millions of smaller ones. Pluto is the largest known Kuiper Belt object, but it is not alone in its size class. Eris, discovered in 2005, is similar in size to Pluto and has a comparable mass. Makemake, Haumea, and Quaoar are also large Kuiper Belt objects. The discovery of Eris in 2005 triggered the debate that led to Pluto's reclassification. If Pluto was a planet, then Eris, which appeared at the time to be slightly larger than Pluto, would also be a planet. And the Kuiper Belt likely contained many more objects of comparable size that had not yet been discovered. The solar system might need to add dozens of new planets to its roster. The International Astronomical Union convened a panel to develop a formal definition of planet, and in August 2006 voted on a definition that requires a planet to have cleared the neighborhood around its orbit. Pluto, sharing its orbital neighborhood with thousands of other Kuiper Belt objects, does not meet this criterion. It was reclassified as a dwarf planet, a category that also includes Eris, Makemake, Haumea, and Ceres. The reclassification was controversial and remains contested among some planetary scientists, but it has not diminished Pluto's scientific interest. If anything, understanding Pluto as the largest member of a vast population of Kuiper Belt objects makes it more scientifically interesting, not less. Pluto is a key to understanding the outer solar system and the population of icy worlds that inhabit it. Pluto has 5 known moons. Charon is by far the largest, with a diameter of about 1,212 kilometers, more than half of Pluto's diameter of about 2,377 kilometers. This makes the Pluto-Charon system unique in the solar system. No other planet or dwarf planet has a moon so large relative to itself. In fact, some scientists prefer to call Pluto and Charon a binary system, or a double dwarf planet, rather than a planet and its moon, because the center of mass of the system, the point around which both objects orbit, lies not inside Pluto, but in the space between the two bodies. Both Pluto and Charon orbit around this common center of mass, both orbiting each other. Both are also tidally locked to each other, meaning the same face of Pluto always faces Charon, and the same face of Charon always faces Pluto. If you stood on the side of Pluto facing Charon, you would always see Charon hanging in the same position in the sky. If you stood on the other side of Pluto, you would never see Charon at all. The 4 smaller moons of Pluto, Nix, Hydra, Kerberos, and Styx, are much smaller and orbit at greater distances. They were discovered by the Hubble Space Telescope between 2005 and 2012. They are irregularly shaped, tumbling chaotically in their orbits in ways that reflect the complex gravitational environment of the binary Pluto-Charon system. Nix and Hydra are elongated, irregular objects a few tens of kilometers across. Kerberos and Styx are smaller still, only a few kilometers across. Now let us talk about the spacecraft that crossed the solar system to visit these worlds. New Horizons. New Horizons was a NASA mission led by the planetary scientist Alan Stern of the Southwest Research Institute. Stern had been advocating for a Pluto mission since the early 1990s and had seen multiple proposals fall through before New Horizons was finally approved and funded. He assembled a team of scientists and engineers who spent several years designing and building a spacecraft capable of surviving the journey to Pluto and returning data from it. The spacecraft itself is small by the standards of flagship space missions. It weighs about 478 kilograms, roughly the mass of a grand piano. It carries 7 scientific instruments including cameras, spectrometers, and particle detectors. Because sunlight at Pluto's distance is only about 1/1000th as bright as at Earth, solar panels were not a practical power source. New Horizons is powered by a radioisotope thermoelectric generator which converts heat from the decay of plutonium-238 into electricity, the same type of power source that powered Voyager and Cassini and many other outer solar system missions. New Horizons launched on January 19, 2006. From Cape Canaveral, Florida, it was launched on an Atlas V rocket with extra boosters to give it the highest launch speed ever achieved by a spacecraft leaving Earth. It left Earth's orbit at 58,536 kilometers per hour, faster than any spacecraft had ever moved at that point in its history. On its way to Pluto, it flew past Jupiter in February 2007 using Jupiter's gravity in a flyby that increased its speed by another 4,000 kilometers per hour and bent its trajectory toward Pluto. The Jupiter flyby also provided an opportunity to test all the spacecraft's instruments on a real planetary system before reaching Pluto, and the images and data returned from the Jupiter flyby were scientifically valuable in their own right. After the Jupiter flyby, New Horizons spent most of the next 8 years in hibernation mode. To conserve power and extend the life of the spacecraft's electronics, the spacecraft was put into a sleep mode for most of this period, waking up for checkouts and then going back to sleep. The small team of mission scientists and engineers kept watch over the sleeping spacecraft, monitoring its telemetry, waiting for the years to pass. In January 2015, 6 months before the Pluto flyby, New Horizons was awakened for the final approach. It began taking images of Pluto that at first were little better than the best images from the Hubble Space Telescope. But as the spacecraft drew closer week by week, the images improved. By May and June 2015, they were showing features on Pluto's surface for the first time. Dark regions and bright regions, a polar cap, and hints of something in the Western Hemisphere, something bright and distinctive. On July 14, 2015, New Horizons flew past Pluto at the closest approach of 12,500 kilometers, moving at 49,000 kilometers per hour. In the space of a few hours, the spacecraft's instruments scanned the surface and atmosphere of Pluto and Charon, taking measurements and photographs that could not be repeated. During the flyby itself, the spacecraft was pointed at Pluto and Charon rather than at Earth, so it could not transmit data in real time. The mission team had to wait through the long communication delay and then through the hours of the flyby itself before the spacecraft turned back toward Earth and began transmitting. When the first image arrived showing the full disk of Pluto in high resolution, the heart was unmistakable. The bright region in the Western Hemisphere was enormous, distinctive, and shaped in a way that genuinely resembled a heart. The team named it Tombaugh Regio, in honor of Clyde Tombaugh, the man who had discovered Pluto 85 years earlier and whose ashes were aboard the spacecraft. The naming was deeply appropriate. The heart of Pluto, revealed for the first time, was named for its discoverer. The heart of Pluto, Tombaugh Regio, consists of 2 distinct regions. The left lobe of the heart, called Sputnik Planitia, is a vast basin of nitrogen ice, about 1,000 kilometers across. The right lobe is a region of different terrain, more complex and varied, with different ice compositions. Sputnik Planitia is where most of the extraordinary geological activity on Pluto has been discovered. Let us spend some time there. Sputnik Planitia occupies a deep basin in Pluto's crust, perhaps formed by an ancient impact that excavated a large depression which subsequently filled with nitrogen ice. The surface of the nitrogen ice in this basin is remarkably smooth and young, with almost no impact craters. This tells us that the surface is constantly being renewed. The mechanism of renewal is convection. The nitrogen ice in Sputnik Planitia is thought to be convecting, with warmer ice welling up from below and cooler ice sinking. In the same way that a pot of water heated from below develops convection cells. The gentle heat flow from Pluto's interior keeps the nitrogen ice warm enough at depth to be slightly plastic and buoyant, driving a very slow convection that continuously brings fresh ice to the surface. The convection cells in Sputnik Planitia are visible in the New Horizons images as a network of polygonal patterns across the surface, individual cells typically a few tens of kilometers across, separated by shallow troughs where the cool, dense ice from the tops of adjacent cells sinks back downward. The cells are slowly turning over on timescales of perhaps hundreds of thousands of years, continuously refreshing the surface with pristine nitrogen ice and explaining why the surface is so free of impact craters. At the edges of Sputnik Planitia, the nitrogen ice flows outward from the basin in glaciers, creeping slowly across the surrounding terrain like a slow-motion river, filling in low-lying areas and partially burying craters and ridges. These glaciers are similar in behavior to the glaciers of water ice on Earth, but moving much more slowly because of the lower gravity and the very cold temperatures. They are nitrogen ice glaciers on a world where the average surface temperature is about minus 228 degrees Celsius, only about 45 degrees above absolute zero. The mountains of Pluto are one of the most astonishing discoveries of the New Horizons mission. Along the margins of Sputnik Planitia, rising from the plains of nitrogen ice, there are mountain ranges that reach heights of 3,500 meters above the surrounding terrain. These mountains, named Tenzing Montes and Hillary Montes after the mountaineers who first climbed Mount Everest, are made of water ice, not nitrogen ice, not methane ice, but solid water ice. At Pluto's extreme cold temperatures, water ice is essentially rock, rigid and structurally strong, capable of supporting mountain ranges of significant height without collapsing. The mountains are not geological features in the volcanic sense. They are blocks of water ice, billions of years old, standing at the margins of the nitrogen ice basin, and ranges that look remarkably similar to the Rocky Mountain ranges of the American West when seen in New Horizons images. The contrast between the smooth young surface of Sputnik Planitia and the ancient rugged mountain terrain around it creates landscapes of extraordinary visual drama. The flat white plain of nitrogen ice extends to the horizon. At its edge, the dark water ice mountains rise abruptly, their slopes catching the pale sunlight and casting long shadows across the nitrogen plain. Beyond the mountains, the darker, more complex terrain of Pluto's surface stretches away into the distance. Pluto has a thin but real atmosphere. Before New Horizons, the atmosphere had been studied by observing how Pluto's disk blocked the light of stars it passed in front of. From these occultation measurements, scientists knew the atmosphere was mostly nitrogen, with traces of methane and carbon monoxide, and that its surface pressure was far lower than Earth's, about 100,000 times lower. But the exact structure and character of the atmosphere was unknown. New Horizons revealed the atmosphere in extraordinary detail. As the spacecraft flew past Pluto, it watched the sun set behind the planet from the other side, and the way the sunlight was scattered and absorbed by the atmosphere revealed its vertical structure with precision. The atmosphere has multiple distinct haze layers, more than a dozen separate hazes extending up to about 200 kilometers above the surface. These haze layers are made of complex organic molecules called tholins, produced when nitrogen and methane in the atmosphere are broken down by ultraviolet radiation from the sun and by high-energy particles from space. And the resulting molecules react with each other to form larger, more complex compounds. Tholins are what give Pluto its characteristic reddish-brown color in many regions. The same process of nitrogen and methane photochemistry that produces tholins in the atmosphere also produces them on the surface, where they accumulate and give the terrain a distinctive ruddy hue. The darkest, most reddish region on Pluto is in the north polar area of Charon, a dark cap called Mordor Macula, which we will discuss when we turn our attention to Charon. The methane in Pluto's atmosphere is particularly interesting. Methane ice has been detected on Pluto's surface in regions that are not covered by nitrogen ice. The methane ice appears reddish where it has been exposed to radiation for long periods and undergone photochemical reactions, and bluish-white where it is fresher. The distribution of methane ice across Pluto's surface reflects the seasonal cycling of this volatile compound, which sublimates from one region and redeposits in another as Pluto moves through its long, elliptical orbit and the temperatures across different parts of the surface change. Now let us turn to Charon, the great moon, the companion world of Pluto. Charon is roughly half the size of Pluto in diameter, about 1,212 kilometers compared to Pluto's 2,377 kilometers, but its density is significantly different from Pluto's. Charon is denser in water ice and less dense in nitrogen and other volatiles. Its surface is darker than Pluto's and more uniformly colored, without the complex patchwork of different ice types that gives Pluto such a varied appearance. The most visually striking feature of Charon, visible even in the approach images taken by New Horizons before the flyby, is the dark polar region. In the northern polar area of Charon, there is a large, roughly circular dark region that the team named Mordor Macula after the dark land in Tolkien's Lord of the Rings. This dark region is made of tholins, the same complex organic molecules that give Pluto its reddish tinge in many areas. But on Charon, the tholins are concentrated in the polar region in a way that has a specific explanation. During Pluto's long year, the northern hemisphere of Charon goes through an extreme polar winter that lasts decades. During this polar night, temperatures drop so low that methane leaking from Pluto's atmosphere and drifting across space to Charon freezes onto the polar surface of Charon as frost. When sunlight returns after the polar winter, the methane frost sublimates back into gas, but the tholins that were produced from the methane by radiation during the polar winter do not sublimate. They are too complex and too non-volatile. They remain behind. Over billions of Charon's long polar winters and the radiation processing of each winter's methane frost, the tholins have accumulated, layer by layer, building up the dark cap of Mordor Macula. It is a record of billions of years of cold chemistry, written in dark organic molecules on the pole of Pluto's moon. The equatorial and mid-latitude regions of Charon have a different character. They are moderately cratered, showing a geological history of impact bombardment over billions of years. But there are features that hint at a more complex geological past. Serenity Chasma, a deep canyon system that runs across part of Charon's surface, is part of a network of troughs and ridges that circles much of Charon's equatorial region. This canyon system extends for hundreds of kilometers and reaches depths of several kilometers. It appears to have been formed by the stretching and fracturing of Charon's crust. The most plausible explanation for this global system of fractures is that Charon once had an interior liquid water ocean that subsequently froze. When water freezes, it expands. If Charon had a subsurface liquid ocean early in its history, the freezing of that ocean would have caused the body to expand, stretching and fracturing the overlying crust. The canyons we see today may be the scars of that expansion, preserved in the frozen crust of Charon for billions of years. If this interpretation is correct, Charon was once another ocean world in the outer solar system, another member of the growing family of worlds that once harbored liquid water in their interiors. Pluto itself may also have a subsurface ocean. Measurements of Pluto's shape and the geometry of Sputnik Planitia suggest that the basin may be located above a region of slightly denser material in Pluto's interior, possibly a subsurface reservoir of liquid water. The deep impact basin that may have formed Sputnik Planitia would naturally be expected to be in the hemisphere of Pluto, facing away from Charon, because the tidal and rotational dynamics of the binary system favor alignment of asymmetries in that direction. But Sputnik Planitia is actually on the hemisphere facing Charon. This implies that after the impact, something caused Pluto to reorient itself, rotating so that the basin ended up on the Charon-facing side. A subsurface ocean beneath the basin could explain this reorientation by providing a denser mass concentration that the tidal forces with Charon pulled into alignment. The presence of such an ocean would make Pluto yet another world in the outer solar system with a liquid water interior. One of the most operationally remarkable aspects of the New Horizons mission was the challenge of returning all the data from the flyby to Earth. The spacecraft's radio transmitter is not powerful by modern standards, and the distance from Pluto to Earth during the flyby was about 4.7 billion kilometers. At this distance, even traveling at the speed of light, a signal takes more than 4 hours to reach Earth, and the data transmission rate through the spacecraft's high-gain antenna at that distance is extremely slow, only about 1,000 bits per second. Roughly comparable to the data transmission speed of very early internet modems in the 1990s. The New Horizons spacecraft was able to take far more data during the flyby than it could transmit in the days immediately surrounding closest approach. The spacecraft's onboard memory stored all the data collected and then spent the following 16 months slowly transmitting it all back to Earth at this very low data rate. The last of the flyby data from the Pluto system did not reach Earth until October 2016, more than a year after the flyby itself. Scientists had to wait months after the flyby to see the full data set, with new images and measurements trickling in over that extended period as the spacecraft slowly emptied its memory. After Pluto, New Horizons continued outward into the Kuiper Belt. In January 2019, it flew past a small Kuiper Belt object that had been discovered by the Hubble Space Telescope specifically as a target for the extended mission. The object was initially called 2014 MU69 and was subsequently named Arakoth, a word meaning sky in the language of the Powhatan people of Maryland and Virginia, where the Johns Hopkins Applied Physics Laboratory is located. Arakoth turned out to be one of the most scientifically interesting objects ever studied by a spacecraft. It is a contact binary, two lobes that came together very gently and stuck, forming a peanut or snowman shape. The two lobes, named Arakoth and Wenu, are each roughly 20 kilometers across and are held together by their mutual gravity, rotating together as a single object. The fact that they are joined so gently, without shattering, tells scientists that the two lobes approached each other very slowly, a process called accretion, rather than coming together in a violent collision. The surface of Arakoth is uniformly red, suggesting a surface coating of fallens. It is one of the most pristine objects ever studied by a spacecraft, its surface largely unchanged since it formed 4.5 billion years ago in the outer solar system. Studying Arakoth is like reading the first page of the solar system story. New Horizons is still traveling outward from the sun, moving at about 14 kilometers per second. It has passed beyond the orbit of Pluto and is now in the outer Kuiper belt, becoming only the fifth spacecraft in history to reach this distance from the sun. The others are Voyager 1, Voyager 2, Pioneer 10, and Pioneer 11. New Horizons is expected to continue operating until the mid-2030s, when its power supply will no longer be sufficient to operate its instruments. At that point, it will drift silently onward, becoming yet another permanent resident of the interstellar medium that will carry its cargo of human-made objects indefinitely into the future. There is one more dimension of Pluto's story that deserves mention before we rest: the emotional dimension. Pluto was discovered in 1930 and was a planet for 76 years. Generations of children grew up learning that the solar system had 9 planets, and the 9th was Pluto. When Pluto was reclassified in 2006, the public reaction was remarkable. People who had learned the planets as children felt something like grief. Social media, then just emerging as a public phenomenon, was full of affectionate, humorous, and sometimes genuinely sad reactions to Pluto's demotion. The phrase "poor Pluto" became a cultural touchstone. But before the emotional reflection, let us spend more time on the actual scientific richness of what New Horizons revealed, because the science deserves to be fully understood. The terrain of Pluto is extraordinarily varied, far more varied than anyone predicted for a small, distant, frozen world. There are at least 5 or 6 distinct types of terrain on Pluto's surface, each with a different composition, age, and origin story. The bright nitrogen ice plains of Sputnik Planitia contrast with the dark reddish-brown terrains of the equatorial regions, which contrast in turn with the methane frost deposits that form a polar cap of sorts in the high northern latitudes, and with the complex terrain of the non-Sputnik portion of Tombaugh Regio. The dark equatorial terrains, sometimes called the whale, from their resemblance in early images to a whale swimming across the surface, are among the oldest terrain on Pluto. They are heavily cratered, suggesting they have been accumulating impact craters for a very long time. They are dark because they are rich in tholins, the complex organic compounds produced by the photochemical processing of Pluto's atmospheric gases. Over billions of years, tholins produced in the atmosphere and deposited on the surface have built up a dark, reddish-brown coating on these ancient terrains, absorbing sunlight and giving them their distinctive color. One of the most striking features of the ancient equatorial terrain is a region informally called Cthulhu Macula, another name drawn from the Lovecraftian mythology of dark and ancient things, which seemed appropriate for this ancient dark terrain. Cthulhu Macula is a large, irregular dark region stretching across much of the equatorial belt, heavily cratered and deeply colored with tholins. It provides some of the best evidence of Pluto's ancient surface, preserved relatively unchanged from the early solar system. Among the most geologically complex terrains on Pluto are the bladed terrain regions found primarily in the mid-latitudes near Tomball Regio. These regions show a surface covered in elongated ridges or blades of methane ice, each ridge perhaps a few hundred meters to a kilometer in height, and extending for tens of kilometers in the direction perpendicular to the prevailing direction of atmospheric methane vapor transport. These ice blades form by a process called sublimation, where sunlight heats the methane ice on the tops of ridges and causes it to sublimate, depositing the vapor in the shadows at the bases of ridges where it recondenses. Over millions of years, this process would sharpen and extend the ridges until the landscape takes on the distinctive bladed appearance seen in the New Horizons images. Analogous features are found in South America, where sunlight at high altitude creates pointed ice formations called penitentes in snowfields, though at a much smaller scale. The detailed analysis of Pluto's surface composition was made possible by one of New Horizons' instruments called the Linear Etalon Imaging Spectral Array, or LISA. This instrument measured the wavelengths of light reflected from different parts of Pluto's surface and compared them to the known spectral signatures of different materials. From these measurements, scientists produced detailed maps of the distribution of nitrogen ice, methane ice, carbon monoxide ice, and water ice across Pluto's surface, as well as the distribution of tholins and other complex organic materials. The mapping revealed that different ices are concentrated in different regions for reasons related to Pluto's complex volatile cycle. Nitrogen is the most abundant ice and dominates Sputnik Planitia and the surrounding areas. Methane ice tends to be concentrated in the high latitudes and in specific bright regions. Carbon monoxide ice is found predominantly in the brightest portions of Sputnik Planitia. Water ice is found in the older, darker terrains where it is exposed as the more volatile ices have sublimated away from those regions. The distribution of these ices is dynamic, changing over the course of Pluto's seasons as different ices sublimate from one region and condense in another. Let us also think more carefully about what the convection cells in Sputnik Planitia tell us about Pluto's interior. Convection requires a heat source. On Earth, the heat that drives convection in the mantle comes from the decay of radioactive elements and from residual heat left over from the planet's formation. On Pluto, the same sources of heat are present, though weaker, because Pluto is smaller and has a lower concentration of radioactive elements, but they are sufficient to drive a very slow, very gentle convection in the nitrogen ice of Sputnik Planitia, because nitrogen ice at the temperatures found in Sputnik Planitia is remarkably easy to deform. It flows and convects under very small temperature differences because of its physical properties at those extreme temperatures. The rate of convection in Sputnik Planitia, as inferred from the size of the convection cells in models of nitrogen ice rheology, suggests that the surface of the nitrogen plane is completely overturned every 500,000 years or so. This is extremely fast by geological standards, fast enough to explain why there are essentially no impact craters on the surface of Sputnik Planitia despite the fact that the basin itself is probably ancient. Any craters that form on the nitrogen ice surface are erased by the convective overturning within a few million years. The relationship between Pluto and its moon Charon also involves a remarkable history of formation. The current leading hypothesis for how Charon formed is similar to the giant impact hypothesis for the formation of Earth's moon. Early in the history of the solar system, a large Kuiper Belt object collided with the proto-Pluto at relatively low velocity. Because Kuiper Belt objects move more slowly relative to each other than inner solar system bodies do. The collision was not so violent that the two bodies were completely vaporized, but it was energetic enough to blow material off both bodies and form a cloud of debris and orbit around the combined mass. This debris then coalesced into Charon and the 4 smaller moons. The evidence for this scenario includes the similar densities of Pluto and Charon, suggesting they formed from the same material, and the orbital characteristics of the moon system. After the formation of the binary, Pluto and Charon tidally evolved toward mutual tidal locking, each one slowing the other's rotation until both rotated at the same rate they orbited. This process is complete. Pluto and Charon are now both tidally locked to each other, perpetually facing each other with the same hemispheres, orbiting around their common center of mass with a period of 6.387 Earth days. The Kuiper Belt itself, the context within which Pluto exists, is one of the largest and most significant structures in the solar system. It extends from about the orbit of Neptune at 30 astronomical units out to about 50 astronomical units. Beyond the main Kuiper Belt, there is a region called the scattered disk, where objects have been scattered into more inclined and elliptical orbits by gravitational interactions with Neptune. And beyond the scattered disk, extending perhaps 1,000 to 100,000 astronomical units from the Sun, is the hypothetical Oort cloud, the vast reservoir of long-period comets. The Kuiper Belt contains an estimated total mass of roughly a few percent of Earth's mass, distributed among hundreds of thousands of objects larger than 100 kilometers and many more smaller ones. These objects are the remnants of the outer solar system's planet-forming material, the icy equivalent of the asteroid belt's rocky material. Unlike the asteroid belt, which was depleted by Jupiter's gravitational influence, the Kuiper Belt was shaped primarily by Neptune's gravitational interactions, which scattered many Kuiper Belt objects into the scattered disk, and ultimately into the inner solar system as short-period comets. The composition of Kuiper Belt objects, as inferred from their spectral characteristics and from the samples returned from Arrokoth and the composition measurements of Pluto and Charon, reflects the pristine material of the outer solar system. These bodies formed at temperatures where water, methane, nitrogen, and carbon monoxide all condense as ice, and where complex organic chemistry has been building up for 5 billion years under the influence of cosmic radiation and solar ultraviolet light. They are among the most chemically complex natural objects in the solar system, carrying a molecular diversity that reflects billions of years of cold chemistry in the outer regions of the solar disk. The New Horizons mission is part of a broader effort to understand these outer solar system worlds. The proposed mission concept, called New Horizons 2, or successor missions, would target other large Kuiper Belt objects to explore the diversity within this population. Understanding the range of sizes, compositions, and geological histories among Kuiper Belt objects is essential for understanding how the outer solar system formed and how it has evolved over 4.5 billion years. The science returned by New Horizons from the Pluto system continues to generate new discoveries years after the flyby. Scientists are still analyzing the full dataset, still finding new features and new patterns in the images and measurements. New papers are published regularly, each one adding detail and nuance to the picture of Pluto that New Horizons revealed. The mission was a scientific triumph that will be generating discoveries for decades, and then New Horizons arrived, and the heart was revealed. The discovery of Tombaugh Regio, the vast heart-shaped plain of nitrogen ice, arriving in the images that New Horizons sent back in July 2015, was met with an outpouring of public emotion that surprised even the mission scientists. The heart felt like Pluto was welcoming its first visitor. It felt like the solar system's most distant, most overlooked, most frequently dismissed world was making a statement about its own character. We had demoted it, and it showed us its heart. The story of how Pluto was demoted, and then how New Horizons arrived and transformed our understanding of it, is, in miniature, the story of how science works at its best. First we discover something, then we try to understand where it fits within our existing categories. When our categories turn out to be inadequate, we revise, and in the process of revising our categories, we are forced to look more carefully at the objects that challenged them. The closer we look, the more extraordinary they turn out to be. Pluto challenged our category of planet and forced us to develop better definitions. In the process of that debate, we paid more attention to Pluto in the Kuiper Belt than we might have otherwise. The New Horizons mission was partly motivated by the desire to understand Pluto properly, to know what this demoted world actually was. And what we found when we finally looked closely enough was a world of glaciers and mountains and haze layers and a beating nitrogen heart. A world more complex and more alive than any geologist or planetary scientist would have predicted for an object of Pluto's size and distance from the Sun. The debate about Pluto's classification is not entirely settled, scientifically speaking. Some planetary scientists continue to argue that the definition of planet adopted in 2006 is inadequate and should be revised. They point out that under the 2006 definition, Earth itself would not be classified as a planet if it were located in the asteroid belt or the Kuiper Belt, because in that context it would not have cleared its orbital neighborhood. They argue that a planet should be defined by its intrinsic properties, its size and shape and geological activity, rather than by its orbital context. Under any reasonable intrinsic definition, Pluto is a planet. It is round. It is geologically complex. It has an atmosphere. It has moons. It has glaciers. It has mountains. It has a convecting nitrogen ocean on its surface. Whether Pluto is classified as a planet or a dwarf planet will not be settled by this story. It is a question for the scientific community to continue to debate and refine. What matters more is understanding Pluto as it actually is, in all its extraordinary detail, rather than as any particular category label would lead us to expect it to be. The universe does not organize itself into the categories we invent. it presents us with objects that are always more complex and more surprising than our categories can contain. Pluto is one of the clearest examples of this in the history of planetary science. The broader lesson of Pluto extends beyond the classification debate. It is a lesson about the dangers of assumptions and the rewards of looking closely. For 85 years, we assumed Pluto was a small, simple, frozen world at the edge of the solar system, not worth the enormous investment of sending a spacecraft there. The scientific community debated for years whether a Pluto mission was justified given the cost and the competing demands for spacecraft resources. When New Horizons was finally approved, it was one of the cheaper NASA missions of its era, with a total cost of about $720 million, modest by the standards of flagship missions, and what it returned was extraordinary beyond all expectation. Every time we have sent a spacecraft to a world that had been observed only from a distance, we have been surprised. Mars turned out to have an extraordinary geological history: ancient rivers, enormous volcanoes, a canyon system that dwarfs anything on Earth. Jupiter turned out to have a magnetic field that dominates much of the inner solar system and a storm system of atmospheric complexity that still defies complete understanding. Saturn's rings turned out to be made of billions of individual ice particles, each on its own orbit, interacting in ways that create structure and gaps in waves that continue to fascinate scientists. Every world is more than it appears from afar. Pluto was just the latest and most dramatic demonstration of this truth. The New Horizons spacecraft is still traveling. It is now in the outer Kuiper Belt, in a region that has never been directly explored by any spacecraft. Its instruments are still working, still measuring the particle and dust environment of the distant outer solar system. The team continues to look for additional Kuiper Belt objects that the spacecraft might fly past on its outward journey, though the opportunities are limited by the spacecraft's trajectory and the density of suitable targets in this part of the belt. Each measurement it makes in this unexplored region adds to our understanding of how the outer solar system's structure and environment change with increasing distance from the Sun. When New Horizons finally falls silent, sometime in the 2030s, it will join the Voyager spacecraft and the Pioneer probes as silent ambassadors of humanity traveling indefinitely outward into interstellar space. Aboard New Horizons, in addition to the ashes of Clyde Tombaugh, there is a compact disc containing the names of 434,000 people who signed up to have their names sent to Pluto. There are also 2 United States quarters, a Florida quarter and a Maryland quarter, representing the 2 states most associated with the mission. And there is a small piece of Spaceship-O, the first privately developed spacecraft to reach space. These objects will travel forever with the spacecraft, carrying a small fragment of human history into the darkness between the stars. Whatever its official classification, Pluto is an extraordinary world. Complex, geologically alive in ways that should have been impossible at such extreme cold and distance. Beautiful in the pale light of a sun so distant, it appears only as a very bright star, and now known to us in a way it was not before July 14, 2015, Clyde Tombaugh found it in 1930. He spent his life wondering what it looked like up close, as ashes rode across the solar system for 9.5 years. and when the spacecraft carrying them finally reached Pluto, it looked down at the planet he had discovered and found it more extraordinary than anyone had dared to imagine. You are very close to sleep now. Let everything settle gently. Let Pluto drift peacefully behind your closed eyes. The white heart of Tombaugh Regio gleaming against the darker terrain, the nitrogen glaciers creeping slowly across the plains, the water ice mountains standing at the edge of the Great Basin, the pale hazes layered above the thin atmosphere, catching the faint light of a very distant sun, and Charon hanging in the black sky, always in the same position, slightly larger than the moon appears from Earth, its north pole dark with billions of years of accumulated organic chemistry. The solar system extends much farther than we once thought. Pluto and Charon and the Kuiper Belt are not the edge. Beyond the Kuiper Belt lies the Oort cloud, a vast spherical shell of icy bodies extending perhaps halfway to the nearest star. But Pluto is the frontier we have visited, the last large world that human spacecraft have explored up close. And it has a heart. Sleep now. Let the cold beauty of the outer solar system settle around you like a blanket. The sun is a bright star from where Pluto orbits. But you are warm and comfortable and home on the small blue planet where the light is bright and the air is sweet and everything you need is here. Good night.